our next session. It's a spotlight presentation where our eminent speaker, Mr. Siva Brahman, CEO and Managing Director at Jaajitech, will take us through real-time heat monitoring and optimization strategies. Requesting Mr. Brahmam to on his video, and before he takes over, I would like to share a brief profile of his as well. So, Mr. Shivrama Brahmam has a total of 22 years plus of industrial experience, which includes manufacturing operations, process control and optimization, digital transformation, software development, entrepreneurship, and much more. He has previously worked with Nagarjuna Fertilizers, Kakinad, Indian Oil Corporation, Mathura, Aspentech, ME Kuwait before starting Jaji Technologies during April 2013. His aim has been to provide integrated digital solutions for power plants and the manufacturing industry. The company provides solutions for more than 75 companies across multiple industry verticals. Mr. Brahmam, thank you for joining us today, and over to you to take the spotlight presentation forward.
Thank you. Thank you, Shriyal. Can you hear me?
Yes.
Okay, so let me share my screen. Can you enable my...
I have just done that.
Okay, right. Okay, so I'll share the entire thing. Okay. Yeah. Can you see my screen now?
Yes, I can.
My voice is clear, right?
Perfect.
Thank you. Thank you. Yeah, thanks for this opportunity, Shriyal. And yeah, thanks for the introduction, by the way. Though, I'm coming from a vendor perspective, where we provide digital solutions for power plants. Jaajitech has about 15 plus Indian power plant as customers, where we provide EMS, ABT, performance monitoring solution, digital logbooks, and then the maintenance logbooks. Like, there's a lot of talk on the RCM today. I'm very happy to hear that. And yeah, so though I come from I don't want to pitch as a solution here. I want to talk a little bit generic in nature, how to calculate heat rate on real-time, using some of the real-time technologies. Though the whole solution, what I'm talking about is actually what we deployed in a Mexican power plant 2 months back. But I removed all my company logos or power product, logos, so that it looks like a pretty generic, presentation. So I don't want to commercialize this particular presentation. So I want to talk more on theory and how you can actually use the technologies to do a real-time heat rate monitoring and optimization. With that, with your permission, I would like to start. And so thanks for the eminent speakers today who talked about the various aspects of reducing heat rate, and then they were improving the efficiency. And then they talked about various aspects, where they can actually minimize the heat rate and improve the overall profitability. Now I'll be focusing mostly on the actual calculations and process, how you do it and what benefits you get it, how to implement this thing in a real time. This is a real thing that you can actually do in your power plant right away, with our technology or any other technology in the market. Okay, I'll be focusing most on practical purposes, how you can implement a heat rate monitoring in your power plant. Okay. Now, there are many challenges we have in heat rate monitoring. To be frank, I worked with 15 plus power plants in India, including NTPC, was also a customer, and Semco, Adhanik Power. I see that Adhanik Power was the last time winner. And then we worked with companies like Ratan India, or NPL, Nava Power Plant. So many of them don't have the real-time heat rate calculations. I don't know what's really happening here. I'm really happy to see this conference. Then we tried, but I think there's a need for implementing these technologies to have a real-time heat rate calculations, monitoring and improving thereby the overall efficiency. So there is a reason why it is not implemented in these power plants. One such reason, or you can say challenge, is that the complex calculations, on thermodynamics that are involved in this particular process. It's not a very simple expression that you can implement very easily. And then lack of performance curves, or maybe the curves are more not relevant because of the upgrades and changes. And then lack of real-time visibility and a platform for KPI and drill down. And then lack of real-time or less availability of performance dashboards. And also there are lengthy calculations and manual reports to generate these energy efficiencies or heat rate calculations, or the drill down to the individual efficiencies of condensers or generators or steam turbines and all. And then one of the most important thing, the point was highlighted earlier, the data. He was talking about one of the speaker expressed a concern about the validity of the sensor data, which can mislead sometimes. Yes, I agree totally. And then there's something called data validation and reconciliation, where we can actually run a QP in order to ensure that the data which from the sensors is adjusted such a way that you get the better and reliable readings. So it's basically data validation and reconciliation module has to be embedded inside the heat rate calculations. So that will help you to have more accurate heat rates. And then lack of predictive analytics, where which will really give you our visibility on these performance degradations of the future. It will also give you a lot of anomaly detection of the assets. When you talk about RCM, these predictive analytics are very, very important. And then overall, what I see in Indian power plant scenario, though we have 15 plus customers, we pitch to many people, we talk to so many power plant customers, including the top people. So there's a less digital maturity when it compares to the companies in US. I was in US 2 months back. I was talking to some of the power plant people where we were pushing the performance monitoring. I see the adoption of the performance monitoring is pretty high in US compared to in India. So that's where we are trying to push now the performance monitoring in India, and this conference is the right spot. Thanks for having me here. I'll try to cover these things now. Now, coming to the real-time heat rate monitoring, I'll talk really what practically is actually done. Okay, there is a plant, the power plant, and then the data from the power plant comes from different data sources like PLC, SCADA, energy meters, and laboratory or anything. All this data, the real-time data, will be stored in a historian. We offer a historian called Insys Data Historian. It's a Make in India. All our solutions are Make in India, and there was a talk about Make in India technologies in this space. And we are proud that we are offering a Make in India digital technologies for this particular heat rate monitoring. Now, the data historian collects the data from multiple sources using multiple protocols and process the data, archive the data for an unlimited period of time, and then it pushes the data to a heat balance module, a real-time heat balance. There we do a heat balance across all the nodes. Once the heat balance is done, the output of the heat balance will go to thermal performance calculations. I have a separate slide on all these steps. And then this output will go to the optimization module, where you can actually take actual heat rates and other things in order to optimize and also do what if analysis on this. But right now we are not providing the optimization from Jaajitech, but we are providing from a third party. But right now, the data processing, collection, archiving, real-time heat rate balance, heat balance, thermal power calculations, everything is done within our platform. And there are tools available in market other than our platform also. So it's more or less like the technology is available right now at a very cost-effective manner in India itself to implement this real-time heat rate monitoring in power plants. Now, when you go a step ahead and then implement a plant simulation model and then implement an optimizer, then it will give you a much better analysis of how to optimize the overall heat rate by adjusting what. And then the output of the whole thing will go to a data analytics platform, which can be used for further, visualization, monitoring, and troubleshooting, decision making, and all those things. Which comes with web-based as well mobile app. I think the Akhil has mentioned about Android app. Insys comes with built-in apps for digital logbooks, and it has built-in apps for the dashboards and KPI monitoring in both Android and iOS. They are ready-made available, and then we also have an Excel add-ins and all those things. So the tools are available for effective and real-time heat rate monitoring and optimization, and this is the process. Now, coming to the online heat balance calculations. Now, What is the significance? We use online data to do the heat balance. It's very important to do the heat balance so that this output is going for the heat rate calculations. Okay. So in order to have an online heat balance, you need to have a data historian analytics platform embedded so that it will take data from your DCS using OPC or Modbus, and then also the energy meters and the laboratory. And then this data is used for real-time, heat balance. So how the heat balance is done, so you have to draw a boundary and then get all the energy in and out, calculate all these things using the formulas. Most of them are thermodynamic formulas. We use it and then we try to do the heat balance. So there's a lot of calculations are there, series of calculations using our and normally the any platform who offers the online heat balance will comes with the calculation engine which can be used to implement these heat balances and then map those inputs and outputs with the respective sensor data. Now, once the heat balance is done, it also includes the data which is not measured, like some of the design data, some of the gas flow compositions, maybe you enter manually, and also steam turbine exit enthalpies, condenser duty. So all this information which is also be input to the heat balance, and then output of the heat balance will go to the performance calculations. Now, what is the performance calculation does? Like there is a expected or reference curve, like basically the performance curves which are given by the initial base load, and then this curve cannot be used directly because the actual reference temperature is different, and also reference conditions are different, and also the curves have to be retrofitted such a way. Now, so that first what we will do, we will take a reference data and then use the performance curves to calculate the expected power thing, and then use the correction factors to create the corrected heat rate. So what happens, the corrected heat rate is the one which you have to use to compare with the rated heat rate, so that you will know how much is the degradation in the heat rate and how much is the degradation in the efficiency, or the efficiency. So these things we have to, this is a series of calculations that have been done, that will be done in order to achieve or arrive at the final heat rate value. And then this is done at every, let us say, you can do it every 5 minutes, you can do it every 15 minutes. It depends on, like normally we do it every 5 minutes, to calculate the heat rate. So then, so the heat rate and then the degradation, like how much percentage is degraded, and then the power degradation of the turbine and the heat rate degradation, and both can be calculated online, and then that can be converted as a KPI using a KPI management tool. What this tool will do, it will take a KPI baseline value and then current value, and the deviation is basically the gap. And then it will create a balance scorecard kind of thing where you can actually see the baseline and benchmark value and actual target value and the current value, and then you can compare why this heat rate has really is a problem right now, why it is the plant has degraded, what is the reason, what is the efficiency decreased, why it efficiency decreased. All these things you can analyze using input trend root cause analysis. And you can also see a correlation matrix with the input variables with the KPIs, so that what happens, you can quickly identify what is the cause for the degradation, of the heat rate, and also the power degradation in the GTs and other things. Okay, so the efficiency issues, performance issues, can be easily identified using the RCA root cause analysis using using a KPI manager. And then there'll be an action tracker immediately. So whenever there is an issue is identified, then and there they can create an action for the respective maintenance or people. Now the maintenance part also comes very relevant here. People are talking about like the RCM and other things. Like let us, for example, any one of the see, there are many components to this. Why the efficiency came down, there can be many reasons. Now, one can be, the issue can be with the mission or equipment, or it can be with the overall, the coal quality or many other things. So there are many factors that are associated with that. So the RCA will give you exact point out, or you can infer from the analytics that system provides to find out the exact cause and then give a task immediately to the people to rectify that. This task manager, or you can call it action tracker, can be added to the KPI level itself. So there can be many KPIs. The KPIs on the overall plant level, KPIs on the equipment level, like a condenser, condensate rate, or it can be, turbine efficiency. All these things can be a separate KPIs. There can be sub KPIs. So the main KPI drill down to sub KPI, drill down to individual parameters, or drill down to identify the problem and then give action tracker, and then start discussing on the action whether this has been completed or not. So this is the end-to-end platform that can help you to measure, monitor, track, take action on a particular issues related to heat rate performance. Okay. So this has been successfully implemented in a Mexican power plant a couple of months back. And I was in Mexico to go live during the go live of that. Now, this technology is completely made in India, and it can be used in any of the power plants in India. Now, coming to the third step of the predictive analytics and optimization. Now, you see that the data from the plant goes to the historian, and then there's the dynamic model of the plant, and then there's also kind of predictive models which can be used to identify the predicted values and then take the measured values and find the deviation, which will give you an indication where the system is, how the anomaly. So that's how we can detect the anomaly. So detecting the anomalies in the different assets, different performance, degradations will give you an edge to act early, so that that degradation will actually never takes place. So you'll always ensure that your efficiency is higher, And then, of course, there can be many opportunities in the predictive analytics and optimization, the how to identify what if analysis you can do with this kind of models and other things. So to be frank, we don't have the current optimization engine in our platform, but we embed with other third-party models actually. But we have all the other things like online heat rate calculation and KPI management, digital logbooks, maintenance management systems and everything. So this is a brief about how the online heat rate calculations are done on the ground. Now, coming to there are a lot of talk on the digital transformation, digital tools that can help to improve the overall performance of the thermal or any power plants. Now, there are three important areas where a power plant operates. Right, there is a production and the operations team, and then there is a manufacturing excellence or the technical services team, operation excellence team, and there's the maintenance team. Now, when you do a digital transformation, it has to be an integrated digital transformation to cover all these areas to achieve the overall performance. So at Jaajitech, what we do, we provide the digital solutions, for the integrated digital transformation of power plants. So when it comes to the production, we provide the connected assets. We bring all the data of your, PLCs, DCS, SCADA, and all those things, energy meters, ABT meters, laboratory, everything we bring into one platform and provide the data, and then use the data for, heat rate calculation, efficiency calculation, performance monitoring, and giving the real-time visibility in mobile apps and then web apps and everything. And then we provide digital logbooks, a ready-made solution which is available, which is implemented successfully at many places. And then we provide the predictive analytics by implementing the use cases. And we have a very robust ABT and DSN platform, which can be used to reduce the penalties, and then effectively monitor the APC, auxiliary power consumption. So when it comes to the, in the production, there are also many other aspects that can be used to increase the overall, productivity and overall performance. In the process side, operational or performance excellence side, the KPI manager that I was talking about earlier, and then the energy management, that's what we saw, like one of our, hotcake kind of product we have, EMS. So this EMS is, it's very, very efficient. It's not just, it doesn't only talk about the energy meters, it will also communicate with the process and bring all the data together and gives you a contextual visualization or picturization of your energy consumption. It talks about the steam energy, fuel, and talks about the, electricity as well. So it also calculates specific energy consumptions of all the critical equipment like fans, ID fans, FD fans, whatever the boiler, motors, boiler water feed motors and everything, all the assets. You can find out specific energy calculations. So some of them can be an ingredient for the overall heat rate issues. So the system is highly integrated, and then of course the mass and energy balance reports automation. So all these energy reports will be automatically generated, iterate reports, efficiency reports. And then coming to the maintenance side, which is very, very important, and eminent speakers also highlighted this point, which is missing in our Indian industry. Most of the people are whomsoever I talk, they're all either using the Excel-based schedules or using SAP PM. Only again, the updates are very less frequent, but people are not really interested. Are not really updating back into SAP PM because the SAP PM is a bit tedious. Like it's also not very comfortable to enter the data. So even though SAP PM was implemented at some places, it was not effectively utilized in the field. Of course, go back to the control room, they update it, the technician room. But to avoid this thing, we have a solution, or the solutions are available in the market, that the asset, the performance 360, which talks about the asset reliability, and then the maintenance checklist and logbooks. So what does this do? Basically, the maintenance logbooks, basically the operator will take the device to the field, and then he gets the work order synchronized, and then based on that, he will do all the LLF checklists, equipment outage records, and they'll also do PM checklist directly from the mobile and update immediately. It'll go back and sit in the SAP, or if they don't have SAP, the maintenance management systems will be updated automatically. So this digital transformation approach, covering the production, technical services, and maintenance, will improve the overall efficiency of the power plant. So this is what we offer. I didn't put my product names and all. If you are very much interested, anybody is interested, you can you can just browse our website, jaajitech.com. You will get more on all our customer references and other things. So with that, I would like to conclude, and then I'm open for any question and answers.
Shiva, a great presentation once again.
Thank you, sir.
You have been doing a great job, I know, and now I am very happy to see your success in Mexico and US. So in real sense, you are making in India for the world, actually.
We're trying our level best, sir. Yeah.
No, my good wishes. And my only concern is, everybody is developing some kind of software, and they all have their own expertise.
Correct.
And the problem is, all these softwares are working in isolation. They don't talk to each other. And for a user, how many software user will buy? You have your software, our Akela has another software. Then there is one more presentation I am told by TC people. They are also going to talk about some digital technology. So my wishful thinking is that if all can be integrated and all are on the same protocol and communication platform, so that they can talk to each other, and customer gets a fully integrated solution. So what do you say on that?
I agree with you that but the market is consolidating. If you see the history of these things, how the performance is being monitored in power plants. If you see, the gate cycle, recently you talk about Epsilon, other things, and there is a ITA Pro. Okay, so in India we don't have tech for the backend simulation and other things, but of course in the front end we have. For the ABT and EMS, there are many, a couple of players, not very strong players in the ABT, but in EMS, many players are there. But when you talk about the performance monitoring, the kind of solution that we have is very, very good, actually. And we don't have the thermodynamic, engine at the moment, but we are doing that in Excel and then hitting it back into the engine, taking it back into our system. So, but for the traditional heat rate calculations and then the KPI management, performance monitoring, we have everything inbuilt online. We don't have to worry about anything else. For the optimization part, we are right now doing it in Excel, DVR and data validation, reconciliation, and the optimization we are doing in Excel. But other things, and then taking the data back into our system and providing all the visualizations and the things that are required. So whatever we did in Mexico is the 100% online system, taking data through from the DCS using the OPC interface, and then doing a real-time all the coefficient calculations, rated calculations, corrected calculations, and giving them the KPI drilled down, and then find out what is the issue, anomaly detection, alerts and notifications. We also implemented digital logbooks, and then we haven't done the maintenance logbooks. Right now we are doing maintenance logbooks in Aditya Birla. But yeah, I mean, that's a very good point that we can take it to the power plants. I thought, I never see that angle, but most of the power plant customers comes to us for EMS and APT, which is very popular in the market at the moment. So yeah, I think after this conference, I feel that I can go to many power plants and tell about our integrated digital solutions that can help the heat rate. I have that confidence now because many people are talking about maintenance management system, which I was little not sure if the power plants will take it or not, but I think it's a good thing that we should push it to the Indian market.
Do you think the power plant is really open up to discuss about heat rate? Because I have seen heat rate is like a salary which is never discussed openly. I have not seen any document in this country or any place where you have mentioned about, because heat rate is the business thing. It's business secret. So most of the companies they talk everything, but they never like to talk about the heat rate, because based on the heat rate, PPAs are decided.
It has to change. I think that has to change because when I went to US, I met one Rockdale investment company. They own 20 power plants. They're sitting in Houston. So we gave a presentation to
power plants.
20 power plants they own, not coal, I mean gas, mostly gas. And then some of them are combined cycle. So what they were asking me is that since they're an investment firm, they want to ensure that the power plants are operating at highest efficiency. So they want to set up a tool at the corporate level to monitor the performance of the individual units. They just want a dashboard, what is the heat rate and what is the efficiency of individual units, and compare them, which is doing better, which is not doing better. That's how the people look at the power plant. And that kind of approach, I've not seen anything in India at the moment. I'm sorry to say that, but people, less.
I don't think. I remember almost 10 years back, the DOE, Department of Energy, did some project in India with NTPC, if I remember correctly. It was a USAID funded project.
Okay.
And in that project, all the data were brought to the centralized location and it was all analyzed. My only concern is regulation and legality permits such open information sharing and willingness by the management to have the data?
Because they need to monitor. See, at the end of the day, the investment firms invest in power plants to make money, right? If the performance is not good, they don't make money. They just either discontinue that and then take it away. So that's the reason why they continuously monitor the performance of the power plants, and they invest a lot of money in that. And of course, in India, people are not that much interested to monitor the KPIs. But yeah, they're very good for I think they're showing a lot of interest in the digital logbooks and the maintenance logbooks at the moment. We have to take it to the market at the moment. Yeah, those things.
So can you do the heat rate audit? I mean, can you visit a power plant and tell the developers what is the real heat rate and the variation online?
Yeah, definitely. That's what we do. That's what we do. That's what we did in the.
How many days it takes?
See, it depends on whether they have the thermal performance curves available or not. If they don't have, you have to use a simulation tool to generate those curves first. That's a big task. If they have performance curves, we can easily implement it. And then if they have, let us say, DCS with OPC, I can do it in 2 to 3 months time.
2 to 3 months?
Because you want to create a real time and with the validation, other thing, go live and everything. I'm talking about the real time implementation of that, not an audit. It's a real time system implementation and delivery.
And after that, anybody can see the heat rate on real time basis.
Yeah, real time. They can see in mobile. They can get alerts if it is degraded.
Have
if
you
you
done
see some of my screenshots, yeah.
Have you done some project?
That's what Mexico we did. No? We did a Mexico NAS plan we have done.
You share some presentation because there are 2-3 opportunities, and we did not find anybody, so we can discuss it after.
Sure. So we bid for that Rockdale now on US. That's under progress, and we are now bidding for one in Middle East for 5 GTs combined cycle. So we are doing good thing in this performance monitoring.
Thank you, Shiva. Shriyal, over to you.
Yeah.
Thank you so much, Mr. Brahmam, and thank you, Mr. Verma. I think you've been with us all day, and with your queries, we only get more and more insightful details from our speakers joining
Even
us
I'm learning a lot, actually. I learn a lot.
I'm sure, and I think this is a perfect platform to share that information and knowledge and exchange, which is what CE also aims at doing. So thank you so much for that.
To meet old friends also, I mean, we hardly meet, we hardly talk, we just communicate on WhatsApp. So it's an opportunity to know what great they are doing.
I'm glad we are able to offer you that. And Mr. Brahmam, thank you again, once again, for all your time and the insightful presentation that you shared.